So we're going to learn a new strategy. So far we've solved systems equations by graphing. We solved by the substitution method. And now we're going to learn another algebraic technique called the elimination method. And this is my preferred method. This method has a few steps. I should write the steps down. So step 1, I'm going to write both equations in general form. This is the time where general form is my friend. General form means having the x's and the y's on the left-hand side and the constant on the right-hand side. To do step 1 in problem 26, the 3x minus 2y equal to 9, it's in general form enough for me. The x's and y's are on the left side and the number is on the right side. I had a stray mark, it almost looked like a negative 9. The second equation, x equals minus 2y plus 11, is not in general form because the 2y's on the wrong side. So for my second equation, I'm going to add 2y to both sides. When I do that, I get x plus 2y equals 11. That's the end of step 1. Step 2 requires being clever. So what I need to do is, if it's not already happened, I'm going to make one of the variables have opposites for its coefficient. Opposites are like 5 and negative 5, 6 and negative 6. This is the part that requires thinking if it's not already done. For my problem, the y's have opposites for their coefficient. This step 2 is already done for me. Step 3, combine the equations and solve. Combine the equations and solve. Or add the equations and solve. Maybe combine's not the best word, but it's a good word. So I'm going to put a horizontal line under my equations and I'm going to add everything up. I'm going to add 3x plus x. That x in the bottom equation is really 1x. So I'm going to do 3x plus 1x is 4x. I'm going to cancel the two y's because they're opposites. And then 9 plus 11 is 20. I'm going to finish solving by dividing by 4, dividing by 4. That's going to give me x equal to 5. Done with the third step. Now I move on to the fourth step. Solve for the opposite variable. And I kind of have to use substitution. Here I can't. It's solving the same way like we did in substitution. So I'm going to take this x and plug it into one of the equations. I don't like working with negatives. I'm going to plug it right into that equation right there because that equation is loaded up with small numbers and positive. I can use any equation. So I'm going to use the 1x. I'm going to change that x to 5 plus 2y equal to 6. The reason I picked that equation, small numbers, all positives. Now I'm going to minus 5. Should be 11 and not 6. There's an 11 there. Then I'm going to minus 5, minus 5. I got the 6 in my head because I was doing the algebra in my head ahead of time. And then divide by 2, divide by 2. That gives me y equal to 3. I claim the answer as x equal 5, y equal to 3. And step 5 is going to be to check. I'm not going to check too many to keep the video a little bit short. But for the checking part of this, I'd go to the top equation, 3x minus 2y equal to 9. Plug in 5 for x and 3 for y, and make sure that that works. To make sure if I plug in 5 for x and 3 for y, that I'm left with a true statement, which I am. And similarly, do the x equals minus 2y plus 11. Same strategy. Plug 5 in for the x, 3 in for the y. I don't need to worry about the left-hand side. I just need the negative 2 times 3 plus 11 side. And that's going to give me 5 equal to 5. So I know my answer checks. I should check every time, but it gets, it just takes time, and these videos are getting, probably really cumbersome for you to watch. So I'm going to probably punt on the checking, and I have answers written off to the side. I'll check that way. All right, so elimination method is supposed to be my friend. Who knows? Maybe it'll be your preferred method, but in general, I prefer the elimination method to the substitution method. So, step 1 in the elimination method is to get each equation written in standard form, with the x's and the y's on the left-hand side written alphabetically. Top equations written with the x's and the y's on the left-hand side, the constant on the right-hand side. It's good. I'm going to leave the top equation intact. Bottom equation, not in such a good form. So I need to get it in that nice general form by adding 8x to both sides. And I'm going to make this 8x plus 9y equal to 60. That's the end of step 1. Step 2 is where you have to be creative. You need to get the numbers in front of the x or the numbers in front of the y to be the same number with opposite signs. And as I look at the numbers, neither numbers are the same with opposite signs, but the numbers in front of the y's have opposite signs. So I've got that going for me. I'm going to make one of the variables make one of the variables have opposites for its coefficient. Well, I have opposite signs, and I can make that negative 3 the opposite of positive 9. I can make it negative 9 if I multiply it by 3. This is a new skill that we're going to have. We're going to transform an entire equation by multiplying each term in the equation by a number that I pick to make the coefficients opposite. I told myself if I multiplied 4 by 3, negative 3 by 3, and 0 by 3, that's going to make the coefficient of the y opposites, and that's what I want. So for the top equation, I'm going to multiply 3 times 4x and get 12x. 3 times minus 3y and get minus 9y, the opposite of positive 9y, and 3 times 0 and get 0. I'm changing, as opposed to dividing equations like I did with substitution, multiplying. But it's similar, but easier. Multiplying is easier than dividing almost always. Now I'm done with step 2. I've made one of the variables have opposites for its coefficient. Now I'm going to combine the equations. How do I combine the equations? Well, I go 12x plus 8x is 20x. The 9s are opposite, they cancel, and 0 plus 60 is 60. I'm in the solving for the this step in number 3. So now I'm going to divide by 20, divide by 20. That's going to give me x equal to 3. Move on to step 4, solve for the opposite variable, in this case y, like we did when we solved by substitution. Meaning pick an equation, plug 3 in for x and try to find y. I don't like equations with negatives. I'm afraid to use that. Kind of afraid to use that. I'm going to use this. 8x plus 9y equals 60. Any equation that's part of this system is going to work. Sometimes it's good to use the original equations because if I made a mistake doing my rewriting, that mistake is going to get magnified here. But I feel good about what I did, and I can check on a test if I have the time to check. I'm just trying to keep this video manageable, so I'm not going to check. But I could, just like I did a bunch of the problems in the substitution method. I could check. So now I plugged in the 3 for x. I got something that I need to do a little bit more work to solve. 60 minus 24, I believe, is 36. Divide by 9, divide by 9. That gives me y equal to 4. The solution for problem 28 is going to be the point x equals 3, y equals 4. So if you're not wanting to check, the best thing you can do is look at my answers. I have all the answers typed up for both evens and odds, and that's what I'm doing right now. I just printed this out because I didn't want to have my iPad here as well. I have a small desk and I barely have room to do this. Alrighty, 30. Step 1, get both equations in general form. Equation 1 has the x's and y's on the left side, the constant on the right side. It's in general form. Equation 2 has the x's and y's on the left side, also has the constant on the left side. It's not in general form. It's pretty easy to get the second equation in general form. I'm just going to add 11 to both sides for that second equation. And now I'm going to stack my equations that are written in general form. So I get 2x plus 6y equal to 26, stacked on top of 8x minus 7y equals 11. So I need to make it so on this step that one of the variables has opposites for its coefficient. If you can't be clever, you don't need to be clever. If numbers have opposite signs, then multiplying the other equation by its coefficient with positive, it will work just fine. So the y's already have opposite signs. The y in the bottom equation has a 7 in front of it. The y in the top equation has a 6 in front of it. I can be that lazy, and this will make it so the numbers in front of the y's are same number, opposite signs. There are other things to do. If you've done this before, you could be clever. I can look at the x's and say, ooh, I can make this x have a coefficient of -8. I'll show you that in a second. But for those of you that just want to just do something that will work every time, multiply. If you have opposites, multiply the top equation by the coefficient of the bottom opposite sign, and just like I did here. And let me do this now. I'm going to go 7 times 2x is 14x. 7 times 6y is plus 42y. 7 times 26 is 182. With a calculator, I don't mind the big numbers. Bottom equation, 6 times 8x is 48x. 6 times minus 7y is minus 42y. 6 times 11 is 66. I've created the opposites. That's not the only way to create opposites, but that's a mindless way to create opposites. Now I'm going to combine. 14x plus 48x is 62x. The y's cancel, and 182 plus 66 is 248. Then divide by 62, divide by 62, and I get x equal to 4. Need to solve for y. I like equations with positives. I'm going to solve that equation for y. I'm going to do 2x plus 6y equal to 26. And I'm going to change the x to 4 and do 2 times 4 plus 6y equals to 26. This will give me 8 plus 6y equal to 26. And then minus 8 minus 8. That will give me 6y equals to 18. And divide by 6 will give me y equal to 3. Not the only way to get my answer, but is the only answer for 3. Let me show you what I could have done. If you look at the coefficients and pretend like they're denominators of fractions, if you can figure out the least common denominator, if those numbers were in denominators of fractions, that would be a good number. So like if the x in the first term was in the, if the 2 in the first term was in a denominator of a fraction, and the 8 in front of the x was in a denominator of fraction, if we needed to get a common denominator, the common denominator between these two would be 8. That means I could make the numbers in front of the x's both 8, make one of them positive, one of them negative to create my opposites. So another strategy, this is all I needed to do, but another strategy is to consider the coefficients like denominators, figure out the common denominator, make it have common denominators with opposite sign. The common denominator between 2 and 8 is 8. I'm going to make this second effort at solving this different because I'm going to drop out the x's. It doesn't matter if I drop out the y's or drop out the x's. I do poorly multiplying by negatives. I like not having to multiply by a negative. I search for those opposite signs all the time. But I could have done this. Multiply the bottom equation through the top equation through by minus 4. And this would give me minus 4 times positive 2x is negative 8x. Minus 4 times positive 6y is minus 24y. Minus 4 times 26 is minus 104. Now stack the equations. 8x minus 7y equals 11. Cancel out the 8x's. Now do minus 24 minus 7 for the coefficient of the y and get a minus 31y. And minus 104 plus 11 and get minus 93 for the constant. And then divide by minus 31, divide by minus 31, and minus 93 divided by minus 31, it's going to give me 3. Same y part of my answer. I'd need to go back and do some algebra to solve for the x, but that's an alternate approach. There's not one way, a single way that leads you to the answer, and we might solve our problems completely differently because I might think to cancel differently. I might think to cancel the y's, you might think to cancel the x's. As long as you can create opposites with the same coefficient, that's enough for canceling. Finally, I get something written in a nice form. Let's do 31 together. We'll skip on 32. And let me write the answer down from my key. I think my key is correct. So the answer for 31 should be x equal to 3, y equal to 5. It's a single point. So I have a few more single points. So I'm shooting for the answer 3, 5. Well, if I look at this, Boy, I love that the y's have opposite signs. When I have opposite signs, I kind of default to what I just did. I'm going to multiply the top equation by the 5 that's in front of the y in the bottom, and the bottom equation by the 3 that's in front of the y in the top. Why? Because I'm not having to multiply by negatives. That's always good because I make a lot of mistakes, and multiplying by negatives is dangerous for me. And this is going to create opposites. So let me go through the top equation. I'll go 5 times 2x and get a 10x, 5 times 3y and get a 15y, and 5 times 21. I'd be using a calculator all the time because I'm about to make mistakes and I don't want to. Bottom equation, 3 times 9x, 27x, 3 times minus 5y, minus 15y, 3 times 2, 6. Feel okay about that. Now I'm going to add the 10x plus the 27x and get 37x. The y's are going to cancel. I'm going to add the 105 and the 6 and get 111. And now I'm going to divide. Divide by 37. Divide by 37. That gives me, on the left-hand side, just the x because I forced the 37s to cancel. And on the right side, 3. Need to solve for y. I don't like negatives. I'm going to pick the top equation, 2x plus 3y equal to 21, because it doesn't have negatives. And in for x, I'm going to plug 3. And I'm going to go through the algebra to get, hopefully, 5. Because my answer, I've already checked it, so it'll best be right. So I showed all the work, so pause the video if I went way too fast for you. It's just basic algebra, hopefully, that you can do, and give it a go. And I'll march on, so pause the video if you need to finish this up. (33) and 34, they're written in the good form. Both sides are written in general form. I'm in a cruddy position because I don't have any opposites, which means I need to get an opposite, which means I'm going to have to multiply by a negative. If I looked at the numbers in front of the x and thought of them as being in denominators of fractions, if I needed to add fractions that had denominators of 2 and denominators of 3, the least common denominator between fractions that have denominators of 2 and 3 would be 6. That's the number I'm going to need to get in front of my x's. And unfortunately, I need to get a positive and a negative. What I'm going to do is I'm going to make the top equation have a negative 6 in front of the x. And I'm going to make the bottom equation have a positive 6. I need to get opposites for my coefficient. Same number, opposite signs. The number 6 makes sense to me because that's the least common denominator if I'm adding fractions that have 2 and 3 in the denominator. So I'm going to make 6's happen, but if I made positive 6 for both coefficients, that wouldn't be sufficient because I wouldn't get the canceling I need. So to make the top equation have a negative 6, I'm going to multiply through by negative 3. I'm going to go negative 3 times positive 2x and get negative 6x. I'll do negative 3 times positive 5y and do negative 15y. I'll do negative 3 times negative 25 and do negative 75. So that's getting the top to have the negative with the 6. To get the bottom to have the positive with the 6, I'm going to multiply it through by 2. I'm going to go 2 times 3x is 6x. 2 times 6y is positive 12y. 2 times 33 is positive 66. Now I can add. For the y's, I do negative 15 plus 12. and get negative 3y. The x's cancel. For the numbers, 75 plus 66 gives me 141. Ow, that's really surprising for 34. I better look at my answer. I have a mistake somewhere. So I have no idea where my mistake is, but I know I have one. Oh, that's not, because I've choked on a sign right here. This negative 3 times that positive 25 should have been a negative 75. I was getting an alarmingly large solution, and I usually make my solutions pretty small. So I should have had negative 75 plus 66, and I should have had negative 9 written on the right-hand side. This will allow me to divide by negative 3, divide by negative 3. That will give me y equal to positive 3. I can pick either equation and solve for x. The numbers in the top look a little bit smaller, so I'm going to solve for x by using the top equation. I'm going to use 2x plus 5y equals to 25, and I'm going to plug in 3 for y. This will give me 2x plus 15 equals 25, and then minus 15 will give me 2x equals to 10. Divide by 2, divide by 2, that gives me x equal to 5. My answer, this is a real common answer for me. Rarely will I see answers over 10. Good enough point to stop. 4 more problems. I think I could do them quick enough. I'm going to just make this a long video because these go real fast. So in problem 36, I look at the x's, they have the same sign, I don't want to mess with those. I look at the y's, they have opposite signs, I do want to mess with those. The foolproof way to not have to think so much, if you want to cancel out a variable, if you have a variable with opposite signs, multiply by the opposite numbers. I'm going to multiply the top equation by 5, the bottom equation by 4. The reason I'm doing that is it's going to make the y's cancelable. The y's had opposite signs, so I knew I could cancel them pretty easy, and I just took the coefficients and mindlessly multiplied. Now, top equation, I'm going to go 8 times 5 and get 40x. 5 times minus 4 and get minus 20y. 5 times 8 and get equals to 40. Bottom, 4 times 3x and get 12x. 4 times 5y. Really? 36? Oh, this still has a solution. Oh, dumb. 4 times 5y is 20y. I thought this was a no solution. It has a solution. And then 4 times 3 is 12. I was so excited to get to what I thought was the end, and I'm not there. I'm probably going to have to do a part 5. I'm going to add now 40x plus 12x and get 52x. The y's cancel. 40 plus 12 is 52. Divide by 52, divide by 52 gives me x equal to 1. Solve, I'm going to use this equation when I solve for y because it's small numbers and positives. I don't do well with negatives. I don't prefer large numbers. So when I go to solve for the opposite variable, I like to get into the smaller numbers. This is going to give me 3 plus 5y equals to 3. The variable's not dropping out, so it's not a no solution. But when I solve, I get a 0. This is the first time that my answer is going to have a 0. It's okay. That doesn't mean no solution. You only get no solution when you don't have any letters. This is just going to give me 0 for an answer. So my answer to 36 is 1, 0. I don't want to do a part 5. Let's just forget it. I'm going to do a part 5.